Hello everyone, welcome back to our channel. Let's see the next type of fragmentation in aromatic carbonyl compounds. The first one is what? Aromatic aldehydes. In case of aromatic aldehydes, what we are observing? Two types of peaks, those are M-1 and M-HCO. We all know that the first compound is what? Benzaldehyde. In case of benzaldehyde, by the removing a single electron, we are producing the particular molecular ion. Here what we are doing? We are doing alpha homolysis. By doing the alpha homolysis, what is happening? Hydrogen radical is going to be removed and carbon is getting one radical. These two radicals can form a triple bond. That's why this peak is commonly called as M-1 peak. After that, what we are doing? This bond is subjected to heterolytic cleavage. Thereby, CO will be removed and the phenyl group will get the positive charge. So, CO removed and H removed. So, this peak is going to be what? M-HCO. We all know that the benzene ring is subjected to the cleavage further by the elimination of acetylene to form a 4-membered ring. The next one, aromatic ketones. In case of ketones, what we are observing? 2 alpha homolytic cleavages, 2 alpha heterolytic cleavages and McLafferty. In case of aliphatic ketones also, we have observed the similar thing or not? So here also similar kind of situation. See this one, the first one is the what? Homolytic cleavage of this alpha bond. The homolytic cleavage is producing what? CH2 radical and here radical. These two can form a pi bond. That's why you will come up with this ion. This is alpha homolysis. If you come here, this is going to be alpha heterolysis. This bond is going to move towards the carbon. So carbon is getting, this bond is going to move towards this carbon. The carbon is going to get minus charge and this carbon will get the positive charge. You will get a peak here. We are giving minus charge, the minus and plus will become triple bond and we will come up with what? Radical. So this is heterolytic cleavage. Next one, if you do the alpha homolysis here, if you do the alpha homolysis like this, what will happen? Phenyl radical and C triple bond focus. Phenyl radical and C triple bond focus. Suppose if you will do the alpha heterolysis, if this bond is subjected to heterolytic cleavage, what will happen? The phenyl ring will get the positive charge and CO radical will be removed. Phenyl ring and this one. In case of the olefin, in case the ketone is having any kind of gamma CH function, we will observe what? McLafferty rearrangement. See this one. This is the pi bond with respect to the pi bond, alpha carbon, beta carbon, gamma carbon. Gamma carbon is having the hydrogen. That's why transfer of gamma hydrogen followed by C alpha beta homolysis, creating a peak that is commonly called as McLafferty peak. So in this way, we are observing fragmentation in aromatic ketones. In case of aromatic acids, what we are doing? We are observing M-OH, M-COH. How can we get this one? By the alpha homolysis, OH radical will be removed and we will get the carbon radical. The carbon radical and O radical can form a triple bond. That's why this peak is commonly called as what? M-OH. From this remove CO, what happens? You will get phenyl cation. The phenyl cation further subjected to elimination of acetylene, you will come up with this kind of 4-membered positively charged ion. Suppose if we will do the alpha heterolytic cleavage, what is happening? Directly COOH will be removed. Then this peak is commonly called as what? M-COOH peak. In case of esters also similar. OH, COOH. OR, COOR. Same situation. In case of esters, what we are observing, if you have the gamma CH function, we will observe McLafferty. See this one? With respect to pi bond, this is alpha carbon, this one is beta carbon, this one is gamma carbon. So transfer of gamma hydrogen to unsaturation followed by C alpha beta homolysis. The elimination of this particular formaldehyde molecule takes place and you will come up with this ion. Okay. Next, come to the amides. In case of amides, M-NH2, M-CONH2 and NH2 plus. Similar kind. Here we are doing the alpha heterolysis, thereby NH2 radical will be removed and C triple bond O plus will be formed. Okay. Next, removal of CO produces phenyl cation. Suppose if you do the alpha homolysis here, what will observe? pH radical will be removed and here you are getting a radical. This radical and this radical can form a pi bond, thereby you will come up with C double bond O NH2. This is positive charge. Here we are coming up with this is positive. If this is having the gamma CH function, see this one, C double bond O NH CH2H. Transfer of hydrogen followed by alpha beta homolysis. The McLafferty peak is observed here. This is pi bond, this is plus, this is radical, bond, C double bond O, radical, and this is the bond. This is pi bond. Right? In this way we can observe fragmentation in aromatic amides. The next type is what? Aromatic nitriles. In case of aromatic nitriles, what we are observing? M minus Cn and M minus HCN. See this one? In case of nitrile, this is the formation of molecular ion or not? So simply what we are doing, heterolytic cleavage. Heterolytic cleavage removes the Cn radical and will get the positively charged phenyl cation. Okay, this is subjected to further elimination of acetylene. It can produce 4-membered cyclic cation. The next one is important, elimination of HCN from the nitrile. This is very important. See this one, what we are doing? Here we are doing the heterolytic cleavage. The same heterolytic cleavage we are doing here, but here we are doing what? Homolytic cleavage. The homolytic cleavage generates what? Radicals. The heterolytic cleavage generates what? Anions. So, C triple bond and H is removed in the form of HCN. See this one, H radical and C triple bond N radical. Here this is subjected to homolytic cleavage. That's why you are getting what? 2 radicals. Radical and these 2 radicals can form a bond. That's why you will come up with what? CH. These 2 radicals will form a lone pair. Okay. This positive and negative can form a triple bond. Thereby HCN will be removed. After the removal of HCN, what we are getting? Here it is the radical and positive charge. These 2 can form a single bond, that is the what? Triple bond. It can also be represented in this way. Benzene type intermediate is formed. So we are coming up with what? 76 MZ value. Okay. The last type of fragmentation pathway for the compounds are what? Nitro compounds, aromatic nitro compounds. Already we had a clear discussion on aliphatic nitro compounds. The similar kind of cleavage takes place in case of aromatic nitro compounds also. These are the peaks which we are getting. The first one is the what? Generation of molecular ion. How can we generate the molecular ion? By the removal of a electron from the minus charge. We are producing what? This kind of molecular ion. Then this is subjected to homolytic cleavage. pH radical will be removed and we are getting the radical. Radical and radical can form a pi bond. So this is one peak. The second one is what? Alpha heterolysis. Heterolysis creating positive charge on the benzene. Benzene further subjected to cleavages means what? You will come up with the 4-membered cyclicum. This one is the what? Rearrangement. Already we had a discussion in case of the aliphatic nitro compounds. The rearrangement of the nitro compounds takes place to produce alkyl nitrides. So here in this case what happens? Aryl nitrides will take place. Now we are forming the molecular ion at the nitrogen lone pair. Nitrogen lone pair. Then we are subjected to heterolytic cleavage. It can produce as what? Oxygen plus. This is involving in the conjugation. The plus charge shifted towards this one. Thereby we are getting this type of ion. Now we are removing CO to produce 5-membered ion. From the 5-membered ion, if you remove this one, you will get the 3-membered ion, 39 MZ. Already we had a discussion in the previous examples. So if you do the homolytic cleavage at this bond, what we are getting? See this one. By the homolytic cleavage, oxygen will get the radical, nitrogen will get the radical. This radical and new radical can form a lone pair and we are coming up with what? NO plus ion. Which one is removed? PHO radical will be removed. So this is all about the fragmentation procedure of different organic compounds. Okay. So in this way, we are having the fragmentation procedures according to the mass spectrometry. Okay, in the next lecture or next video, we are going to have a brief discussion on instrumentation of mass spectrometry, followed by the real-time examples of the mass spectral analysis. Okay.